Most used oil analysis reports come back with two numbers people look at, shrug, and skip past on the way to the wear metals: total acid number and total base number. Both are measured in the same unit, both deal with the same chemistry, and both are consistently misunderstood in the same direction. People assume one is simply the inverse of the other, and that tracking either one is enough. Neither of those things is true. Start with the total base number, because it is the one most people have at least heard mentioned. Every motor oil formulation carries an alkaline reserve, a built-in chemical buffer engineered to neutralize acids that enter the crankcase during operation. That reserve is what the total base number measures. The unit is milligrams of potassium hydroxide per gram of oil, which expresses how much neutralizing capacity exists in each gram of lubricant. Fresh conventional motor oil typically starts between 6 and 9. Fresh synthetic motor oil starts between 8 and 12. Heavy-duty diesel engine oils historically began at 12 to 20 or higher, driven by the sulfuric acid load from high-sulfur diesel fuel. Modern ultra-low sulfur diesel, capped at 15 parts per million in the United States, has changed those numbers. Current CK4 and FA4 rated heavy-duty oils typically start their total base number closer to 9 to 12. Marine applications and off-highway equipment still running high-sulfur fuels remain the exception, where starting values of 15 to 20 or above are still appropriate. As the oil operates, that alkaline reserve depletes with every acid molecule it neutralizes. A total base number below 2 is the commonly cited threshold where the oil is considered spent on acid protection. Total acid number measures the other side. Where total base number tells you how much defensive capacity remains, total acid number tells you how much acid has already accumulated in the oil. Same unit, milligrams of potassium hydroxide per gram, this time measuring how much base would be required to neutralize all the acid present. Fresh motor oil does not start at 0. A brand new 5W30 synthetic might carry a total acid number of 1 to 2 right out of the bottle because certain additives, including some antioxidants and anti-wear compounds, are mildly acidic by nature. The baseline matters. A single total acid number reading, without knowing the fresh oil's starting point, tells you less than it appears to. As the oil ages, the two numbers move in opposite directions. Total base number falls as it consumes acid. Total acid number rises as oxidation byproducts and combustion acids accumulate. The point where total acid number rises to meet a falling. Total base number is called the crossover, and some engineers use that moment as an oil change trigger. The logic reads clean. Once the acid load equals the remaining neutralizing capacity, the buffer is effectively gone. But that framing oversimplifies. In a modern gasoline engine running Tier 3 ultra-low sulfur fuel, total base number depletion is gradual enough that the crossover often does not arrive until the oil's oxidation products and viscosity have already drifted past where they should be. Waiting for crossover in those applications means waiting too long. There is also a measurement problem that most used oil analysis customers never encounter in the instructions. Two ASTM test methods exist for measuring total base number, and they disagree. ASTM D2896 uses perchloric acid as the titrating agent. ASTM D4739 uses hydrochloric acid. Run the same oil sample through both tests and the total base number values can differ by 2 to 4 units. Most motor oil formulation data is calibrated against ASTM D2896. So if a lab runs ASTM D4739 and reports a total base number of 3, that same sample might return 5 or 6 on the other method. Without knowing which test the lab used, comparing total base number readings across different reports can lead to conclusions that are directionally wrong. Most labs note the method. Most customers never look. Here is where the answer to the original question gets specific. For a gasoline engine in a passenger car or light truck, total base number is the number to watch. Modern gasoline is now low enough in sulfur that acid attack is slower than it once was. The primary threat is oxidation. As total base number depletes, the oil's ability to buffer the acids that oxidation generates diminishes directly. A rising total acid number without a fresh oil baseline is harder to interpret. The primary drivers of total acid number increase in a gasoline engine are oxidation and nitration, the oil thermally degrading over time and reacting with nitrogen oxides from blow-by gases. Tracking the rate of change matters more than any single reading. Slow, steady increases across intervals are the normal signature of aging oil. A sharp spike between two consecutive samples, 2 or 3 units gained in a single interval, signals thermal cracking or accelerated oxidation, and it often points to a condition the driver does not yet know is happening. For gear oils, hydraulic fluids, and turbine oils, the answer reverses. Those lubricants carry little or no alkaline reserve because there is no combustion acid load to buffer. Their total base number, or TBN, starts low and stays low by design. In those applications, total acid number, or TAN, is the primary indicator because oxidation is a dominant degradation mode, and a rising total acid number directly measures how far that chemistry has progressed. Many turbine oil and hydraulic fluid maintenance specifications set a total acid number increase limit as the primary change trigger, rather than a total base number minimum, because the total base number has nothing meaningful to say about a fluid that was never designed to buffer combustion acids. The practical takeaway for anyone running used oil analysis on an engine is to track both numbers across intervals rather than reacting to a single reading. Neither number alone tells the full story. A total base number, TBN, that falls below 3 or 4 combined with a total acid number, TAN, that has climbed more than 2 units above the fresh baseline is a more reliable signal than either number in isolation. Most labs that provide used oil analysis report both, and most customers ignore one of them. The one being ignored is usually the one that would have given the earlier warning.